in the most distant, frozen reaches of our solar system, far beyond the orbits of even the most remote planets and icy bodies we know, lies a colossal, ghostly sphere. This is the OORT cloud, a theoretical shell of icy debris believed to encircle our sun at distances so vast they are difficult to comprehend. It is the final frontier of our solar system, a realm of perpetual twilight and unimaginable cold. For centuries, astronomers suspected its existence, a shadowy reservoir from which long-period comets, those spectacular visitors from the void, begin their epic journeys toward the sun. Today, we're venturing into this enigmatic region to uncover its 5 biggest secrets. What mysteries does this immense cloud of icy bodies hold? And how did it shape the very history of our cosmic neighborhood? Let's begin with our first secret. The OORT cloud is unimaginably huge, a structure of mind-boggling scale. When we think of the solar system, we often picture the planets orbiting relatively close to the sun. But the OORT cloud pushes the boundaries of our sun's gravitational influence to its absolute limit. Its inner edge is thought to begin at around 2,000 to 5,000 astronomical units, O from the sun. 1 O is the distance from the Earth to the sun, about 93 million miles. So, we're already talking about a distance thousands of times greater than our own. But that's just the beginning. The outer edge of the OORT cloud might extend to 100,000 astronomical units, or possibly even 200,000 O. At that distance, you are almost halfway to the nearest star, Proxima Centauri. To put this into perspective, NASA's Voyager 1 spacecraft, which has been traveling away from Earth for over 4 decades, is currently about 160 AU away. It would take Voyager 1 around 300 years just to reach the inner edge of the OORT cloud, and it would take an astonishing 30,000 years for it to traverse the entire structure. The sheer volume of space occupied by the OORT cloud is immense, making the region where the planets reside seem like a tiny, compact core in comparison. This brings us to our second secret. The OORT cloud is not a cloud in the way we might imagine it. The name OORT cloud conjures images of a dense, foggy haze, a thick shroud of ice and dust. But the reality is far different. It's more accurately described as an incredibly sparse, spherical shell of individual icy objects. Despite containing a staggering number of objects potentially, trillions of them, these bodies are incredibly far apart from one another. On average, the distance between any 2 objects in the OORT cloud is estimated to be tens of millions of miles. If you were to stand on one of these icy planetesimals, you would likely not be able to see any of your neighbors with the naked eye. The sky would be a vast, black emptiness, punctuated only by the distant stars and the incredibly faint glimmer of our own sun, which would appear as just another bright star in the sky, offering little light or warmth. So, while the total mass of the OORT cloud could be several times that of Earth, this mass is spread out over an astronomical volume, making it one of the most desolate and empty places in the entire solar system. It's a ghost cloud, present but almost imperceptible. Now for our third secret, and this one delves into its violent origins. The OORT cloud is a collection of exiles, planetary building blocks that were kicked out from the inner solar system. The objects in the OORT cloud didn't form in that distant, cold abyss. Instead, scientific models suggest they originated much closer to the sun, in the same region where the planets themselves were forming billions of years ago. During the chaotic early days of the solar system, the gravitational fields of the giant planets, particularly Jupiter and Saturn, were incredibly powerful and disruptive. As smaller icy bodies, or planetesimals, drifted through this region, they were subjected to intense gravitational tugs. Many of these objects were flung into new, highly eccentric orbits. Some were thrown into the sun, some were ejected from the solar system entirely, destined to become rogue interstellar objects, and a great number were hurled outwards into the far reaches of space. These exiled objects were sent on journeys that took them thousands of times farther from the sun than their original birthplace. Eventually, they reached a point where the sun's gravity was just barely strong enough to keep them tethered, but also where the gravitational nudges from passing stars and the Milky Way galaxy itself could influence their orbits. Over millions of years, these gravitational perturbations randomized their paths, scattering them into the vast spherical distribution we now call the OORT cloud. In a sense, the OORT cloud is a cosmic museum preserving the pristine building blocks of our solar system from a time long past. This leads us to our fourth secret. The OORT cloud isn't just one structure, but likely two. Astronomers now believe the OORT cloud is composed of two distinct regions, a vast spherical outer cloud and a flatter, more concentrated inner cloud, often called the Hills cloud, named after astronomer J.G. Hills, who proposed its existence. The outer OORT cloud is the classic spherical shell we've been discussing, weakly bound to the sun and susceptible to disturbances from passing stars. It's from this region that most long-period comets are thought to originate. A slight gravitational nudge is all it takes to send one of these icy bodies on a long plunge toward the inner solar system. The Hills cloud, however, is thought to be a torus-shaped or donut-shaped region located inside the spherical outer cloud. It is more densely packed and more strongly bound to the sun's gravity. This inner reservoir is believed to be the source that replenishes the outer OORT cloud over billions of years. Objects from the Hills cloud can be gradually nudged into the outer region, which in turn feeds the supply of long-period comets. This two-part structure helps explain the long-term stability of the OORT cloud and how it can continue to produce comets even after 4.5 billion years. It acts as a stable, long-term repository, safe from the frequent disruptions that affect the outermost sphere. And finally, our fifth and perhaps most profound secret. The OORT cloud could be a place where we might find objects from other star systems. Because the OORT cloud extends so far out, its outermost regions can sometimes overlap with the OORT clouds of neighboring stars. The gravitational boundary between our solar system and interstellar space is blurry. This means that it's theoretically possible for our sun to capture icy bodies that were originally part of another star's planetary system, and vice versa. As other stars pass by, their own OORT cloud objects could be stripped away and pulled into an orbit around our sun. Scientists believe that a significant number of objects in the OORT cloud might not be native to our solar system. The discovery of interstellar objects like Oumuamua and Borisov, which passed through our solar system, proves that material from other stars does travel through our neighborhood. The OORT cloud could be a vast repository of these captured interstellar travelers. If we could one day send a probe to study the objects in the OORT cloud, we might not only find pristine material from our own solar system's birth, but also samples from entirely different star systems. Studying these alien objects would provide an unprecedented opportunity to learn about the composition and formation of planets around other stars, without ever having to travel the vast distances to reach them. The OORT cloud may hold the chemical blueprints of countless other worlds. The OORT cloud remains one of the most mysterious and intriguing components of our solar system. It is a testament to our solar system's chaotic past and a celestial library holding secrets about our own origins and potentially the origins of other worlds across the galaxy. It is a realm of unimaginable scale and emptiness, a ghost sphere of exiled comets that occasionally send messengers back to the inner solar system, reminding us of the vast, uncharted territory that still lies beyond our reach. Thank you for joining us on this journey to the edge of our solar system. If you enjoyed this cosmic exploration, be sure to subscribe to Space Repo for more deep dives into the mysteries of our universe.